This is 7th grade, Module 1, Topic 1, Lesson 3, Activity 3.3. Go ahead and read the activity description. Pause here. In this activity, you're going to use different strategies to determine the area of shaded regions inside of geometric figures. I am now going to read and model question number 1, so I highly suggest you take some notes. All right, number 1, it says, in the concentric circles shown, capital R represents the radius of the larger circle, and lowercase r represents the radius of the smaller circle. Suppose that capital R is equal to 8 centimeters and lowercase r is equal to 3 centimeters. Calculate the area of the shaded region. So in this lesson, you're not learning anything new. You're really just putting together the things that you already know. Okay, so if we're looking and trying to figure out the area of the shaded region, let's think about what we already know. If I want to find the area of the shaded region, think about what is happening here. Pause here and take a moment to think. Now, if you said, find the area of both circles and then subtract, you are absolutely correct. That is exactly what we're going to do in this problem. But here's the thing, you got to know what numbers to subtract. That smaller circle is actually being taken away from the bigger circle. So that is exactly how you should set up your subtraction. All right, let's go ahead and solve this. All right, so now let's look at our problem and think about what information it gives us. It says that capital R represents the centimeters of the radius of the larger circle. So I'm going to label that R. And also, remember, the radius is from the center of the circle to the edge of the circle, okay, or the measurement from the center to the edge of a circle. So really, that could be there. I could draw a radius here. I could draw a radius here. As long as we know the calculations and how to find that area, we're good. In the smaller circle, I'll do in blue, and that radius is 3. So here I have the area of the shaded circle is equal to pi r squared, and the area of the inner circle is also going to be solved by using pi r squared. I'm going to show my work on a different slide. So here's just some of my work. I'll explain and walk you through what I did. So the first thing I did was set up the formula. Area of a circle is equal to pi r squared for both circles. Then I filled in the radius. So for the first circle, you should have filled in pi, or you should have wrote pi times 8 squared. And then for the smaller circle, pi times 3 squared. Then when you solve and multiply, you should have gotten 64 pi for your larger circle and 9 pi centimeters squared for your smaller circle. Now, we are not done. Also, if you wrote out 3.14 and solve, you absolutely could do that too, but I did this because it's way quicker, because let me show you. No. Being that I wrote both answers in terms of pi, I can easily subtract by using pi. So 64 pi minus 9 pi would give us 55 pi. And then now I can solve and find my real final answer by multiplying 55 times 3.14. Here's a quick reminder of how to multiply decimals. It's red. So we start with this 5 here. 5 times 4 gives us 20. Carry the 2, drop the 0. 5 times 1 is 5, plus 2 gives you 7. And then 5 times 3 gives you 15. So 1570, you should get on the first row. Cancel out that 5. Cross out those small numbers at the top so they don't confuse you later. Then before we go on to our next factor to multiply, I need to remember I'm now going into a different place value, so I need to put a 0 or an X right underneath that 0. So now I'm working with this 5 here. 5 times 4 gives me 20 again. 5 times 1 is 5, plus 2 gives you 7. 5 times 3 is 15, same exact numbers. And now you can just simply add. So when you add, you get 17270, but do not forget that decimal. Count how many decimal places you got in your number. 2, 0. So then in my final answer, my decimal place is 2 places in. So your final answer that you should get is 172 and 7/10 centimeters squared. Let me write. Now at this time, I want you to, I'm going to read questions 2, 3, and 4. And then on your own or with a partner, you are going to answer, showing all of your work and critically thinking, what do I do to get my answer? So question number 2 reads, a circle is inscribed in a square. Determine the area of the shaded region. One thing I want to point out here is that the measurements of the square are not clearly identified, but think about what you know about circles and the parts of a circle. Moving on to number 3. Number 3 reads, two small circles are drawn that touch each other, and both circles touch the larger circle. Determine the area of the shaded region. Again, mark this up, annotate, and think about what you know about circles. And then number 4 says, Jimmy and Matthew each said the area of the shaded region is about 402 square inches. Compare their strategies. So you'll look at the strategies that Jimmy and Matthew both used, and then answer questions A, B, and C. What did Jimmy and Matthew do the same? What was different about their strategies? Which strategy do you prefer? Pause here, answer those questions, and then we will go over them. So for question number 2, here's my work. As you can see, I've marked up my circle and my square so I can clearly see what my measurements are. We know that the radius of that circle is 15, and we know that the full distance, or let's say this, 2 radius, we know creates a diameter, which spans from one side of the circle to the other, and that can go in any direction. And when I notice that, it's kind of off center a little bit, and when I notice that, I can see that the full length of that square is 15 and 15, which would give us 30 all the way around. And what do we know about a square? That all of the sides are the same. So you should have set up your your formulas, and then solved by doing this. We want to know, the question asks, I want to know the area of the shaded region. So think about that last and final step. What would you have to do? Subtract. So we're now going to subtract the circle from that square. However, this 225 pi needs to be written out, not in terms of pi, so that we can subtract it. You should get 706 and 5/10 meters squared when you multiply 225 times pi, which is 3 and 1400ths. Now we have to subtract. Now the subtraction I am going to show you, because I know sometimes it can be a little confusing. So we've got 0 minus 5. We can't do that, so we have to go to our neighbor. This 0, 0. We have to keep going to our next neighbor until we can find something to borrow from our neighbor. So this is a 0, a 0, a 0. So I have to go all the way to this 9, and I'm going to borrow from this 9. So that becomes an 8. This person is the person that borrowed. They now have 10. But we need that first 0 to have something so I can subtract 5. So again, this guy would borrow from this neighbor. That becomes a 9. This becomes a 10. And finally, this guy can finally borrow from his neighbor, and he gets 10. So now I can subtract 10 minus. So the final answer that you should get for the shaded region of this figure is 193.5 meters squared. And that's question number 2. Here's question number 3. I'm about to show you my work for that. But before I do, you should have noticed that these radius give us information and hints to the measurements of all 3 of these circles. So the radius we know is the measurement from the center to the outer edge of the circle, and 2 radius we know make a diameter. And this diameter, I can also show it going across the center of the circle this way and across the center of the circle this way. And so that then tells us that this radius is 8, this radius is 8, this radius is 8, this radius is 8. So that means that the full diameter of this larger circle, I'd have to multiply 8 4 times, or just add it up 4 times, which would give me a diameter of 32. That's what that is. All right, and now for my work. As you can see on the screen, I solved for the area of the larger circle and also the 2 small circles. So the larger circle gave us an area of 256 inches squared, And the two smaller circles, when I multiplied the area of one circle times 2, you got 128 pi inches squared. But that is not our final answer. One final thing that you should have done or should have noticed is that both of my answers are in terms of pi, so I can easily subtract now. So now we have 128 pi, but when we multiply 128 pi by 3 and 14 hundredths to get our final answer, you should get 401 and 92 hundredths inches squared would be the area of that shaded region, which you can also estimate to be about 402. And question number 4. So if you looked at this carefully, you could have noticed that Jimmy and Matthew did the exact same work that we just did. They solved the exact same problem. So now let's answer questions A, B, and C. Question A said, what did Jimmy do and Matthew do the same? You could have said something like, they both completed, you could have said something to the effect of, they both solved for the area in the same way or the same fashion. Part B says, what was the difference in their strategies? Well, if you noticed, Jimmy wrote out 3.14 every time for pi, and Matthew simply used the pi symbol, similar to what we just did. And notice also that they got the same answers. So both ways and both strategies work. And part C says, which strategy do you prefer? Go ahead and tell a neighbor. And then let's move on to question 5. Now, question 5 is 2 parts, an A and a B. I'm going to read both, but using what you just learned and also what you've been learning about circles and area and the radius and the diameter, put all of that learning together and you're going to solve on your own. So number 5 says, determine the area of each shaded region. A, one medium circle and one small circle touch each other and each circle touches the large circle. So you're figuring out the area of the shaded region. Part B says a rectangle is inscribed in the circle. So again, figure out the area of that shaded region. Pause here. So here's my work for 5A. As you can see in purple, I calculated the area of the larger circle. And with that, when I plugged in my radius, and also one more thing you should have noticed, when you drew your diameter all the way across the circle, you should have gotten 3 plus 3 plus 12 plus 12, which gives you 30 for the diameter. And then when plugging in the radius, you split that. So 15. Pi times 15 squared gives you 225 pi. And then for my smaller circle in blue, I calculated the area to be 9 pi. And for my medium circle in green, I calculated the area to be 144 pi. After doing all of these calculations, there's still one last final step you need to do, and that is subtract. Subtract those two smaller circles from the larger circle. So I subtracted 225 pi minus 9 pi minus 144, and that gave me 72. Now, 72 pi is what I would have to calculate to get my final answer. And when you calculate 72 times 3.14, you should get 226 and 8 hundredths centimeters, nope, just kidding, meters squared. And that is your final answer. And here's my work for 5B. So in pink, I calculated the area of the circle using pi r squared. From my diagram, I saw that my diameter across the full distance across the circle was 10. To get my radius, I split that in half. So you should have gotten pi times 5 squared. That gives you 25 pi. And when you multiply 25 times 3.14, you get 78.5 centimeters squared for the area. Then the area of the rectangle, area is equal to base times height. 8 times 6 gives you 48. And now you can simply subtract. When you subtract, you should get your answer of 30 and 5 tenths centimeters squared. And there's your answer for 5B. In summary, we can use familiar formulas to determine the area of shaded regions in geometric figures. Awesome job today.